You guys say that like it's new information for me. Just trying to record for our friends that are missing. So Maddie's facing this. Yeah. I'd say most people probably won't.
I've only watched one.
That's my guess.
That was with the other.
You claim you watched more. I think before you've been like, oh yeah, I'll watch it. I've only watched one.
Whenever I do a review, it's more. I didn't have the notes, so I just like wrote down.
I don't care.
What's your favorite instant hot?
I would guess that you watched some too. What's my favorite one?
Yeah, what is your favorite instant hot recipe?
Let's get our job done here first. Then we can talk instant pot. Well, see, I do, so it can't be like an offhand, like. so on Tuesday.
So listen here.
It was T sub 10, T sub 40, and Z. That's supposed to know what. I gave you so many good tips on that. Well, what? Yeah, six, you don't know? This is me putting this on the desk with the person that's not here to pass out to the rest of the people in the building. Six? You could know six. It's possible. You probably forgot it, but yeah, you learned it. Well, yeah, I have said it before. Whether you learned it or not is up to debate. What do you mean, which TCDF goes on? Like the greater than or less than? Yes. Yes. Absolutely. I would think you'd more understand, like, you look at the upper part and the lower part. It's not really memorized.
No, they have
Either
the
one, either tail. So the first couple, I don't know how he's there, but first one is probably one of the easier ones. So this would be, it's greater than, I'm not going through them all right now, I'm just going to do a couple to get started. But, this is greater than, our T is 3.05, so we want like the upper tail. So we would do TCDF 3.05, comma 999, and then you need degrees of freedom. That comes out to 0.033. 0033. For the second one, we got a couple things going on. So Z is negative 1.9. So we're way over here. We want to find this tail, but it's a not equal to test. So after we find this tail, what do we have to do with it? We have to double it. So I did 2 times normal CDF of negative 999 up to negative 1.9. And that got me 0.057. So now we got a couple other things here. I want to know if the test is statistically significant. What does that mean? If it's statistically significant, what do we do with H naught? Reject. So we just talked about that yesterday for the first time. Statistically significant means you reject H naught. I didn't tell you alpha here, so what is it? 0.05. So my p-value is bigger than alpha, so would I reject H naught? No. So is it statistically significant? we fail to reject, right? And if you fail to reject, it's not statistically significant. So that's no. You memorize that. I just wrote it. Are 1 and 2 okay? Good. Number 3, we can go through. We can knock that out too, I guess. Someone give me one question. So I give you like a story problem, and you have to do a process. Yeah, give me one. Means and proportions. Test or interval. How do I know if it's test or interval?
Yes, no.
Like a yes, no question or an estimate, and then 1 data set or 2 data sets. We okay for 1 through 3? Alright. P-value definition is actually written on the backboard. It would probably be a good idea to memorize that. I can like talk through it in a second just to clarify or try to explain it more, but I would write it down somewhere and I would memorize it and get it in your head. So if you take a picture of it, A, you're never going to look at it. You're a liar, you're not going to look at it. And writing helps you remember.
I don't have to look back. You don't know what you're writing now.
That, okay.
Wait, what if you don't know what you're writing? I don't know what
Well, I'm going to explain what it means. But right now, just write. Can I read what? I can, yes. Oh, you want me to read it out loud? I was just reading it. Like, you want me to like say it all so you can copy it down? I'm not gonna do that. You could look at the photo. You could move like I don't know 2 feet.
And the photo too.
You could look back at your old notes where we've written it down. You could Google it. All of these things allow you to find the answer without me involved. Can't believe you're asking the teacher for help. That's just absurd. Not asking for help, though. Asking for me to read to him because he's lazy.
All I could think was just when you were pointing at that smiley face, he goes, HL actually, because HL, he goes,
Alright, you try to copy the feedback definition down from the mark.
It was so creepy. It was
oh,
great.
yeah, he did it to Jesus.
sub 10, T sub 40, and Z.
Was it the thing where it's like if the number's bigger, the thing gets narrower? Oh my god, I got one! Swag. It's swag.
Isn't it?
It's like
The
when
old
the
Mike
number is
Tyson,
bigger,
yes.
the
Is that- is-
number gets bigger than
It is, yeah.
Does that mean it's a
like narrower.
T with
And then if it gets
same size
small
plate?
and then
Or-
bigger.
That'd be like 10 degrees of freedom. Right?
So then like T40
Same one,
is
yeah.
smaller.
and then Z is the entire population. So it's
Well, Z is like a normal distribution, yeah. So
So Z.
the idea is that as this number gets bigger and bigger, we get closer and closer to this.
So it'd be like.
is 7
So that's like T 10.
It says estimate.
T 40 would be like a little bit more like that.
That,
Z would be like even more like that.
like more narrow.
Yeah.
Oh, I thought Z was like just normally. Oh, I thought you said it was like normal.
As the number here gets bigger, it gets closer and closer to the true
So
normal
then Z
curve.
is like the whole population.
Z is like the true normal population, the true normal
So that
curve.
would be like the highest number.
Yeah, so if you put like T 1 million, it's basically Z.
Okay. So then it would be like. So like that. But prettier. Really good roller coaster. Really weird day.
Are we still like looking at these, or are we ready to go over them, or are we still going through them? Okay. Okay.
Probably go to number 6. You lost me at confidence.
Yeah,
Like I know what confidence interval, but I don't know how like physically.
we don't
What
use
is that?
confidence intervals for the.
But you can.
Well, not
is what
yet.
But yeah, you can, is what I'm trying to get at.
You didn't teach us.
So if you're 92% confident the true mean is between 7 and 9.5, what would you do with the idea that mu is 10? You reject it.
Reject it, and your alpha is 0.8.
What do we-
Rejected. And then alpha would just be like a default.
No.
No?
Alpha and the confidence interval add up to 100%. So if it's a 92% confidence interval, your alpha
I do
is
remember
like
you saying
8%,
that.
but you use 0.08.
I do remember you saying that.
I said everything on here except for the power one. But it's just like I've said it like here and there. We haven't focused on it.
You said it like 3 times. We started this.
That one I gave you.
It wouldn't be as powerful.
Alright, let's take a look at these. Again, these are ideas that will come up on your test, will come up on the AP test, and we're going to do practice AP problems the next couple days and a review. So you'll see them again, but this is like stuff that we have kind of brushed the broad surface of, but not really quite gotten into all the way. We did do p-value. We spent some time on that. You guys don't remember, it was before break. But it's just a hard concept. So the p-value tells me, so let's say that I claim my IQ is 180. It's not 180, that's absurd. And then I go take an IQ test. And I get, isn't that unreasonable that my IQ is 180? Jeez.
Yes.
So, and I get a 140. Alright? Is it possible that my actual IQ is 180 and I just had a really bad day? The probability of what I just said happening is a p-value. So p-value is if my IQ really is 180, the p-value represents the probability that I would be this far away from the mean or further. So if this is true, there is a probability that when I'm this far away, it's just like bad luck. I just had a bad day. I just didn't sleep well. I was in a fight with my wife. Whatever. I'm not focused. So there's a I don't really fight with my wife.
That was a very dark.
No, that was my wife. I don't fight. I don't know why I said that. I was trying to think of things that would make me in a bad mental state.
Us.
So there's yeah, like my IQ is 180, but Robo was in the room, so I just get dumber. So this is the probability that the results are due to random chance. And so when this probability is really low, it's probably not due to random chance, and that's when we go back and we're like, okay, that's probably a lie. That's a tough concept. A shortcut, lame way to remember it is this is the p-value is the probability H naught is true. It's not perfect, but it'll get you to the right result usually. And in the absence of understanding it, write it down and memorize it. Like that works. Because it's going to be a multiple choice question. And if you just got to remember the wording, you can usually weasel your way there, even if you don't fully understand it. Increase the power of a test. So this is like you could spend like a month on this topic in a college stats class. It'd be like the class after this intro stats class. And on the AP test, they present this to you, and they want you to know like one thing about it. Every power question I've ever seen has asked the exact same answer. To make the test more powerful, just think about like what would convince you a test is more powerful. You would want more data behind it, right? So the more sample size you have, the more powerful a test is. So to increase the power, you increase N. Basically, you're just trying to get more data. Does that make sense to you that if I have more data, then you're going to be more convinced in my result? The more powerful statement is a stronger outcome. So all you have to know about power, even though it's like this crazy deep topic, is that if you increase N, you increase the power. Lowest to highest variance here. So we've talked about this before with T's and Z's. So Z is the perfect normal curve. Like if I could draw a perfect one, that's a normal curve, that's Z. We use that for proportions. For means, the bigger that our degrees of freedom are, so like here our degrees of freedom are 40, the closer we are to Z. So like if I had T sub a million, it'd probably basically be Z. But the smaller T is, so this would be like your T40, and then your T10 would kind of look more like that. So the smaller sample size you have, the wider variability you have, the more spread out your data is going to be. And as you get a little bit more data, it gets a little bit tighter. And if you had a perfect normal curve, that's as tight as it can get. Do you guys remember seeing this on the board like a while ago? We haven't. It's been a while. I'm not saying like, why don't you remember? I'm just trying to point it out. All right, number 7. So we did this with the 0 a little bit in confidence intervals, but we can do it with anything. So if I claim that mu is 10, and we do a confidence interval, and I'm 92% sure that the true mean is between 7 and 9.5, what am I going to do with this claim that it's 10? I'm going to reject it, right? Because I'm pretty darn sure the true mean is somewhere in there, and 10 is not in there. So I'd reject it. What if this was 7 to 12.5? Now it's including the 10. Now I would not reject because 10's in there, so that seems reasonable. And the other part of this is that's your confidence interval. Your confidence interval and your alpha have to add to 100%. Except alpha, you don't write as a percent, you write as a decimal. So if this is 92%, your alpha is 0.08. If this was 99%, your alpha is 0.01. They just have to add to 100. Good there? These last two are, I think, a little easier. If I reject HO when alpha is 0.05, what do I know about my p-value in this case? If I rejected alpha, or if I rejected H0, what's true about my p-value? it's lower than 0.05, right? That's why I would have rejected. If it's lower than 0.05, is it automatically also lower than 0.01? What about 0.03? You know what I mean? So it could be that I reject this, but I don't reject this. Do you just say backwards what you were thinking? So this is false. Because, for example, p-value could be in between those. So 0.03, let's say. I would reject at 0.05, but I would fail to reject at 0.01. But the other way around, which I think is what you were trying to answer, if alpha is 0.01 and I reject it, what do I know about my p-value? It's lower than 0.01. If it's lower than 0.01, is it going to be lower than 0.05? Yeah. Anything lower than 0.01 is also lower than 0.05, right? Okay, I'm getting like half of you not paying attention, half of you looking around. Some people, not, what's the issue here? Because I'm not getting like full attention. Too hard? I'm boring? What's going on? Is it like, do you have questions? I'm not mad. I'm trying to figure out why people aren't paying attention or what I can do about it. Because these are things you have to know. Does it make sense that if it's smaller than 0.01, it's also smaller? You know, if I have less money than 1 cent, do I also have less money than 5 cents? Yeah. Any questions on any of that? Okay. I passed out that sheet, right? Flip it over, and I think there's like a blank page on the back. Write this down. This section here. You can write this down too, actually. This will also be helpful. Everything in black. You don't really care about the area of isosceles triangles. Maybe you do. You can write it if you do care. Why is this a thing? Write that down. That doesn't involve talking about Mrs. Mahoney or some nice substitute or looking out in the freaking parking lot. We're gonna help you out. This class doesn't slide.
No, we said you're feeling whack. This class.
Oh, like today's class?
Yeah.
Yeah, something's whack today. Good Lord, what? There is stuff on the board over there written in a black marker that has to do with statistics. Write it down.
Don't make me yell at the recording.
What do you want it to say? I mean, leave. I don't care. I'm not going to stop you. But if you're going to be here, I mean, you could attempt to follow direction.
Said I brought your IQ down.
Seriously. Write down the stuff in black, but it says H-O. What? What am I supposed to do with that? All of it!
He said the stuff in black. So write down the stuff that's in black.
I just thought it was different because it's separated.
Okay, everybody, let's take a chill pill. Everybody, breathe in. Breathe out.
When's leave?
Next to you.
Mr. Davis!
Hey, I had
What are you doing?
I had 3 hours of sleep that
You
night.
are becoming
I
the
was
very
feeling
thing you
great.
hate.
I don't know how else I could have explained to right now. I'm so confused.
This is actually not what it's for. I know something else. At least I know I'm supposed to write down HO.
What are you saying, Nathan? I ain't calling you a truther. So what should I have said besides write down the stuff in black?
What you said was totally right.
No, I honestly.
You said it right. I was just confused because like the two things are separated, so I was like, well, like.
So I should have said write down all of the stuff in black. That would help.
Yeah, I guess.
That's really what everybody thinks.
How you gonna get teacher recommendations for this course?
I mean, it's Mr. Porter.
Yeah, it is Mr. Porter. He just wants to get rid of us.
Oh, I see. That makes sense. What I got, I think.
Are you having trouble too?
No, I finished
It's
reading
the
it. I was just like,
Everybody else is done writing. except for-
Everyone's done writing except for that back.
What are you talking about? Twitch live stream.
I don't even know how to teach this anymore. I don't know
I
anything.
didn't think it was possible for me to feel dumber, but now after this conversation, not our conversation, just this class conversation.
like, how can I wrote it? I guess I wrote it.
Oh.
Like, it just made you dumber that you always like, no.
She's black. It's like leap years this year. AP classes go to Wait, what? AP classes go to D2
During the SAT, but you'll be taking the SAT.
Oh, just like hugs.
Aren't you not gonna be here doing some?
I'm trying for the SAT, so some of you will be able to
It's my last name.
Yeah, that's how they like work that.
Hopefully he means I want to take a picture.
During the SAT,
All I gotta say is
It's
I
fine.
actually, no, it's good. Like, I actually really, you won't get mad at all.
Good, 'cause, like, some tests, I swear.
225.
I was in an SAT.
Okay.
I said D's so much.
So, I know I had to exaggerate. So, there are, like, when we make a conclusion, when we say we reject or we fail to reject, we're not 100% sure ever. Unless that p-value is straight up 0. But even, like, when we've written down 0, it's always like 0.000001, you know? So that p-value gives us, like, a probability of an error. And we might be wrong in our conclusion. And we can't really know that unless we look at all the data, but there's two types of errors you could make, and we're kind of saying, okay, if we could look at all of the data. So if our conclusion is HO, and I can't really accept HO, but like I failed to reject. I decided HO was okay. And I dig deeper into the truth and I get all the population data and I find out the truth was HO, well then I'm happy, right? Like that's what was supposed to happen. If I rejected HO because I think HA is better, and then I dig into the truth and I find all the data and I find how HA was better, well then I'm happy. So these are the two things we're hoping for. That's what usually happens. If you reject HO and you're convinced to move to HA, but if we really could dig deeper and find the truth of what's going on, what's really true is HO. So you screwed up, you rejected HO when you shouldn't have. That's called a type 1 error. Opposite would be I thought HO was okay. Like I wasn't convinced to move off of that and jump to HA. But if I really could see all of the data, what's really true is HA. That's called a type 2 error. And so I don't think either of these are tough. It's just a matter of keeping which one is which straight. And this might help you over here. So if I ever reject HO, the only possible type error is a type 1. And if I ever fail to reject HO, the only possible type error is a type 2. So let's look at a couple examples on the sheet. And I don't know why I stapled this backwards, but there's actually notes on the last page. This is going to blow people's minds. Like, I can't even get people to write things down on the board, and I got the notes on the back page. So there's notes back here that'll help you kind of remember. Let's just do that one now. So type 1 error. It's rejecting HO when you shouldn't have. You think ha, but it's ho. So I know some people do this. They'll go ha, ho, ho, ha. And like this is what you Yeah, like the quotient rule. Yeah, that's not. It's not hard to mix up. It's not as easy to mix up. So whatever trick works for you, like yeah, those people start doing this every year. Like, oh well, if Santa Claus says ho, and that's ha, he's not real. So this, like, everyone has their own little weird way, or I don't even know if that made sense, but everyone has their own kind of like mind trick to get there, and that's fine. It's whatever works for you. But let's look at an example of it. So if I read through, so let P equal the percentage of people that would vote to impeach the president. Let's say it takes 75% of the vote. So we got our HO and HA. So I want you to take a second and I'll do the first one for you. They want two things. They want to know what would a type 1 error be, and then what would the consequences of that be. So a type 1 error is when we think ha, but it's really ho. So this would be we think P is greater than 0.75, but it's really not. So that's what is a type 1 error. Well, the consequences would be like, what are our actions based on that? What did we do that we actually shouldn't have? This is the part where you like tell me about it.
Oh, I honestly thought that was rhetorical.
No, go for it. Like, opposite. If I think P is greater than I would have impeached, but I was wrong. So if P is greater than 0.75, what would my response to that be? Impeach, right? But I was wrong. So the consequence would be we impeached, but we shouldn't have. Yeah, everybody laughed at us. But that's it. I mean, you just have to keep it straight which one is which. So type 2 error would be the opposite. We think P equals 0.75, but it's actually P is greater than 0.75. But actually P is greater than 0.75. So what happened as a result of that in this situation? I didn't impeach, but I should have, yeah. Does that make sense how it works? So the hard part's keeping it straight. Keeping straight which one is which. Go to the front page, please. Sometimes the consequences are like not that big a deal. Like number 2 is about M&Ms. So like you think you have enough M&Ms, but you don't. Like that's not a big deal. Sometimes it's impeach or don't impeach, or like innocent and guilty. That's a big deal. So innocent and guilty. This is like a very common, situation. The jury makes a decision, but the jury's not always right. They're usually right, I'd say, but they could make mistakes. So if we look at it this way, a type 1 error is we said ha, but it's really ho. So we said guilty, the person is innocent. And then, like, what's the consequence of that? Wrongfully convicted someone's a great way to say it. We put someone in jail that we shouldn't have. So we wrongfully convicted someone. I mean, you could say any of those phrases are fine. We put someone in jail that we shouldn't have. We fined someone that we shouldn't have. I don't know what the accusation was here. It could have been jaywalking. It's not a big deal. It could have been murder. I don't know.
Could have been anything.
Loitering.
Could have been asking about me.
So what's type 2 error?
Use of all
Just the
the second is better than the first, according to our justice system.
We're gonna stop right here. We're gonna focus on the stats. Okay, thank you. If we have more time, I wouldn't mind doing a lot talking about it, but we just don't. So we said innocent, but the person is guilty. So what's the consequence? Guilty person goes free. Does what I'm teaching make sense?
Yeah.
It's just a matter of keeping it straight, I think. Try number 4. Number 4 is a good one. 2 and 3, the consequences are, like, my questions weren't very good on those, but 4 and 5 are good. There's a lot of people that when they first get, like, you guys have a test on Monday, you know? As soon as they get their test, they'll write this down. And then, like, it's out of your brain. It's there. You don't have to, like, think about it anymore. But that's kind of what I memorize. I don't have any real trick to it, but that's my kind of go-to shortcut, I guess. Or you can just write it on the box. Like, if you memorize the box, I think that's helpful. Yeah, so it'll always ask you like that. Yeah. You're gonna put context in the consequences anyway, probably, but as long as it's somewhere, you're good.
So when we say that, like we think that all the defective parts, we think that they were more than 100,000.
Well,
They
but they actually weren't.
Would you say, but P was actually equal? Or
No,
would you
you
say
can't say
it's
that.
because it could be less than?
Yeah, you'd say we thought there were more parts defective than there should have been, but there actually weren't. So you're allowing for equal more or less.
Gotcha.
And the opposite too, technically. Like, it's a hard thing to explain to someone.
It
It doesn't really. Tens, hundreds, thousands, 10,000s. No, it's right.
Boom, you're wrong.
You're gonna nitpick. You should be right. And then go ahead and do number 5 if you. 4 and 5 are the 2 I really wanted to get to. So, I'm writing up the answer 4, so check that as you're going, I guess. In the type 2 consequence.
Yeah,
Yeah,
so
that's
it's better
bad.
to die.
Yeah.
So it wasn't scrapped. No, just the airplane crashed.
This thing is
You might have just screwed over a lot of passengers.
bring to this course.
Follow.
That's fine.
We should fix parts.
So,
I thought we might have just screwed over some passengers.
so type 1 would be we think ha, but it's ho, which means I think the parts are bad. So I go through all that process and fix it, but I didn't need to, so just a waste of my time and money. Type 2 would be I think ho, but it's ha. So I thought everything was fine, but really the parts are screwed up. So I'm putting people on planes with parts that are screwed up, and that's fine. Yeah.
Do we have to put like actual numbers? Because I just put like context. Like we think
What'd you
parts are defective, but they are.
That's totally fine. Like you need context somewhere. I just put it more in my second part than my first. But yours is probably better. How many out of number 4 were correct? You guys are picking up what I'm putting down?
Yeah.
Alright. Okay. So for 5, type 1 error would be we think B is greater than 0.05, 0.05, but it's not. So if I think the probability is too high, what am I going to do? What's the consequence here? Yeah, so we don't use a drug that like could have been helpful, right? Does that make sense? And then type 2 would be the opposite, so we think P equals 0.05, but P is greater than 0.05. And that would be we put a bad drug or an unsafe drug on the market. That's fine. Or nasty side effects or something. So that's the last like real topic we had to get through. Remember your con is due tonight. If you want to be eligible for the retake or recovery or whatever. Tomorrow and Friday we'll do review, practice tests, practice AP problems, etc. Your test is